Swayam Prabha. Digital India. Educated India.
Actually, what is the real difference between homogeneous and heterogeneous? When do you call a reaction homogeneous? When do you call a reaction heterogeneous? See, the phase difference is LKG answer. Now you have graduated, so I think you know the correct answer you have to tell. When do you tell? Whenever there is no mass transfer limitation in any phases, then you have the homogeneous. That means again I told you, American society, you do not have to see another molecule for getting married, right? Yeah, immediately it is available, right? You do not have to go to other house, search and parents and all that. So, but in solids, what is really happening? I have two solids coming together for reaction, both are pure, but reaction can automatically take place. Why? Because those molecules are not movable, right? So, that is why what you have to do is you have to break this solid, you have to break this solid, make them very fine powder, if possible molecular level, you can never do it. So, then you mix them perfectly and then bring to temperatures, high temperatures, then the molecules start diffusing a little bit, that is called self diffusion. Okay. So, with that only it will react, that is why solid reactions are very slow. Fastest reactions are gas. Okay. So, that is why again please do not tell what is the difference between homogeneous and heterogeneous means one phase, two phases, over, that stage is over, you have to learn something new. Okay. You can tell that anyone asking if there is what is the definition of homogeneous, if you say that all molecules, I mean whatever number of reactants that are available, if all of them are easily available in one phase, then you have homogeneous. Okay. Heterogeneous, that is not possible, necessarily from one phase to the other phase the molecules have to move, right. So, if you have coal and oxygen, by keeping coal in one room and oxygen in one room you cannot have. Even you have same room, but if there is no sufficient temperature, the reaction temperature, still coal may be there, air may be passing over that, still you do not have reaction. That means the mobility of the molecules is not enough for the reaction to take place, or activation energy what we say, right. Yeah. So, that is why you have to bring them to the reaction conditions environment, and then automatically the molecules will move and the reaction takes place. That is the difference now, actual difference. You want to ask something? No, you blue banyan, you only, I am talking about you, straight. No, you said like this, so I thought you were asking. Yeah,
so
Kalpana.
Homogeneous throughout the reaction?
Yeah, that is a good question. In fact, during the reaction, if it is remains homogeneous, we take them as homogeneous, right. But immediately when the reaction is taking place, there may be a condition where the products are forming as precipitates, okay, solids, like for example. Gas it cannot happen, but mainly it may be happening only in liquid phase. So, if that is not affecting your rate of reaction, then you can call that as only homogeneous. Okay. So, in fact that is the point which I have to also tell, I have forgotten at that time when I was talking. So, now that is a good question, where during the reaction if the molecules are freely available, even though there is a phase change, that means the product when it is formed automatically it is precipitated, you may be stirring it, but I think still you have at molecular level the availability of molecules for the reaction to take place. Okay. So, that is why you can still take that one as homogeneous only. Good. So, that is what we have discussed here with this diagram, and we have also identified what are called catalytic reactions and non catalytic reactions. Now, we have to identify in gas liquid mostly what is the kind of reactions you will have. What kind of reactions you will have in gas liquid? Are they catalytic reactions or are they non catalytic reactions? Mostly there may be one reaction, very peculiar reaction, where you have liquid gas liquid, right, the first one gas liquid. So, liquid acting as a catalyst or gas acting as a catalyst, is it really possible generally? So, most of the time for gas liquid NC non catalytic reactions, right. Okay. So, for liquid,
No.
you think, I say, you are only just listening to me, you have to also think, you have to question me, you have to think. Okay, yeah, huh? Both possible, good, answer is right, but why? Autocatalytic is homogeneous, can be homogeneous. Autocatalytic is the product acting as a catalyst. Okay, now we want to use as external liquid as catalyst, both are liquid, right. So, there are many reactions where there are non-catalytic reactions and also catalytic reactions where one of the liquids can act as catalyst. Okay. I think the nitration reactions are like that. Okay. Nitration reactions are like that, where you have to if there is a catalyst, that catalyst in the form of liquid, okay, will be this liquid reaction. The moment you put solid here, then it becomes 3 phases. If the catalyst is in solid form, then you cannot take this, you have to go here. Now you have 3 phases, no, solid. So, that is why when you are talking about catalyst here, that catalyst must be one liquid, but it should be either miscible in this or in this. Okay. Then the reaction will take place at the interface, and most of the time, that is why one of the liquid is dispersed into very fine droplets, the other liquid is continuously sent, and you have to now see in which phase your catalyst must be dispersed, either dispersed phase or either continuous phase, right. So, that is the condition for the catalytic reactions in liquid, it is possible, few reactions are there. Then what about liquid solid? Yeah, liquid solid, most of the time, what is my liquid solid, gas liquid, yeah, liquid solid can be non-catalytic or catalytic, because for example, that solid can be a catalyst, over that you send liquid, but now this one liquid. So, that liquid is the reaction is taking place on the surface of the catalyst or inside the particle. So, that is possible. So, you have few reactions which can be liquid solid, either catalytic or non-catalytic. Okay. Next one, gas solid. Most of the things are catalytic and also of course non-catalytic reactions. Give me one example of gas solid non-catalytic, which I have told also just now. Rusting, carbon burning, combustion. I think that is very easy for imagination. No? So, carbon burning, even rusting is not that easy to imagine. Again, your mind has to go to cycle and all that. But here carbon means burning immediately comes to our mind, because all of us thousands of times seen this burning. So, that is the reason, and many people would have not seen the rusted cycle. Okay. So, that is why that it takes time. Solid, most of the time it is non-catalytic. Solid. I mean, how do you get a solid, one solid catalyst, another solid only, but how do you make it? How the reaction can take place? Impossible. And one example can you give for solid reaction, which you see every day almost, if you take coffee? That product you use because of the solid reaction. Chinese are very famous for that. Chinese are very famous. I have given you so many clues, I say. What is that? Roasting of what?
Coffee beans.
No, it's not. I am not talking about coffee. When you are taking coffee, use this product. And I gave the clue, beautiful clue, Chinese. Chinese are famous for what? What is that? Charming. You see, because you are interested in junk food, you remember only noodles. Okay, and noodles are kept where? In a plate. What is that? Ceramics. Ceramics and glass Chinese are very long time they have developed the technology. The best ceramics in the world available only in China. And how do they do it? Solid reaction. and solid solid reaction has not come to the level of gas liquid reactions or gas solid reactions or liquid liquid reactions, because they are very difficult to study. Okay. So, that is why I think this is one of the very very difficult reactions, very slow reactions, and you need, I think China, they take that one as an art, the ceramics. It is not only simply they are producing the plates, they produce that plates with beautiful designs, paintings on that. You can just imagine how they are doing it, and lifelong it will be there unless you break it. Okay. So, the painting will never go, the glossiness will never go. It is wonderful, right? You would have seen many movies of Jackie Chan, where fighting will be only how to save one jar. That fellow will come and hit, and he will jump and then catch, and again that fellow will come and hit, and this fellow will go and then catch the jars. No, you have not seen, Abdul? Seen, no? Yeah, we have also seen movies. Yeah, because I appreciate the Chinese jars, not Jackie Chan. Okay. You appreciate Jackie Chan and also try to see what is that he is trying to hold there. In many movies, he will never allow others to break Chinese treasure. That is Chinese treasure really. Okay. So, that is the one. And gas liquid solid can be both catalytic or non catalytic. Okay. I think mainly it is catalytic, when compared to even non catalytic. Okay. This is again technological interruptions. Yeah. So, this is we have to put brackets here. This also is very important for us. Then we should know that, as I told you, the design of non catalytic reactor and the design of catalytic reactor will be totally different. So, that is the reason. Okay. So, now next one, because you have so many possibilities and the rate of reaction when you are expressing for homogeneous, it is very very easy, right. So, normally we write for an ith component, because A, then you can replace this one by A. Okay. Yeah, my equal to, normally I will also write the equation V I, sorry, V dni by dt. Yeah. Okay. dni by dt equal to, I am writing this in terms of moles of I, of course, if I do not put here it is formed, but because negative I am putting, it is reacted per unit time per unit volume. That is the definition. Okay. Yeah. Similarly, we can now write for all other things that are possible. I told you this is the simplest one. This is the simplest one, because volume means here we are talking about volume of the reaction mixture. Okay. Normally, we do not waste our reactor volume. So, that is why when you calculate this, we also think that that is the reactor volume. Actually, it is a reaction mixture, right. If you are conducting slightly at high temperatures and if there is some vapor coming and all that, so that is why you will again allow some kind of vapor space above the liquid. Okay. That is only engineering judgment. How much you have to leave only depends on the temperature, how much vapor is produced and what is the vapor pressure and all that. Okay. But what we are talking here, this volume is volume of the reaction mixture. Okay. So, now when I go to different things now, let me take very widely used is gas solid. Okay. Gas solid is very very, so many reactions are there in the industry. Some of them can be catalytic, some of them can be non catalytic. So, now we will use that one for deriving, writing some equations. That is homogeneous, this is heterogeneous. So many possibilities are there. So, now based on volume of voids, you have to be very clear in the reactor. Okay. So, if I write here again I, yeah. So, moles of I converted per okay, per unit volume per time, right. So, this can be of course meter cubed or second, generally meter cubed per second. I think in chemical engineering literature you get these values, those units in various forms, right. And if you take some of the books, deliberately they give also feet cubed, okay, lb moles, feet cubed and all that, because I think this is required for us. You cannot say that SI, I do not understand anything other than SI units. You should be able to convert one from the other. Okay. Otherwise, consistently use only one system, so that you will get the volume also in that particular system. If you are using only everything in FPA system, finally the volume should be in terms of feet cubed. Okay. So, like that. So, this is the one, and you see here we are now basing on voids in the reactor, and that much you should know. We have a packed bed and you pack all the catalyst particles, for example, in between the particles you have some voids, and inside the particle also you have some voids. We are not talking about that, we are talking about only voids. Okay, tell me, for packed bed how much is the void age? Huh? 0.4. Yeah, any other guess? I am not saying it is right or wrong, it can be wrong also. External? External void is what I am asking. Yeah. 0.5. No, you do not answer, because I think we simply say 0.3, 0.4, that is strictly valid for what? Rashigring means KK will use AK-47. Okay. Yeah, right. For Rashigrings he is 0.4. What is this? I say 2 courses, BTech and MTech. I am talking about them. Okay, PhD scholars. Yeah, I don't know whether you are PhD scholar or MTech. PhD. Yeah, you see. So your Rashigrings are always having only 0.4. 0.4 for what? This is what I say. Still we have only LKG knowledge only. We do not have more than that. Our brain is not expanding. Yeah, tell me, you are just keeping quiet. Jahnavi, 0.4 he said, for what? 0.35 to 0.4. Which packing? And he said Rashigrings, I said no. You can guess, there are many packings, no? Oh my God. Yeah, Sushmita? No idea. Huh? What is that?
HCP hexagonal pack.
What is that packing? Hexagonal. HTP. Hexagonal packing. Oh my God, Margaya, no one will make hexagonal packing. How can you make hexagonal packing so easily?
Regular, irregular packing.
Huh?
Regular and irregular packing.
Very nice answer. What is irregular? What is regular? Tell me.
Regular means we place it according to our wish, like what, in which manner we want. Irregular means we just
Dump. That is called random packing.
random packing.
Okay? Yeah, it is not, because in regular and irregular packings, okay, there are thousands of variations, but this 0.3 to 0.4 will only come for one glass beads. Okay, glass beads can be spherical, cylindrical, they can be Rashigrings, type, with a hole, many things can happen. Glass beads are strictly for spherical particles. Please remember, when you say 0.3, 0.4, okay, strictly for spherical packings. And as he said, I think Rashigrings will have how much? Any other value? 0.6. Okay. Yeah, and bell saddles also around 0.6. Okay. So that is why we have various packings, but except spherical packings, all other things will have higher void age. Okay. Good. Yeah. So that is what is the best. This equation is based on. This is voids. Right. Okay. So then next one is, yeah. So we can also based on volume of catalyst particles. So, again this is, of course, I can put here dashed, double dashed I, yeah, equal to moles, same thing, I converted per volume of solids per time. Yeah. So, based on weight of the particles, again I can write here, oh sorry, okay, moles of I converted, then yeah, weight of catalyst, cat we will write, per time. Good. Yeah. So, another one can be based on external surface of particles. This again minus 4 moles of I converted per surface area per time. Yeah, not able to read. The first one is always moles I converted. Surface area, yeah, of what? Which particle? I have only one particle, catalyst. That is why I said, heterogeneous gas, liquid, gas, solid system. Okay, yeah. So, you have only that solid particles. Yeah, you will have definitely all these doubts, because you have to specifically mention on which you are going to write the rate of reaction. This is very important. Please do not take it away, a very simple definition and all that. No, because finally what you get is only this one in the reactor, in the reactor design expression. When you are calculating, like volume of reactor you calculate, right. So, if you base it on volume of reactor, then you will get volume of reactor. If you get weight, you will get weight. If you get volume of solids, you will get volume of solids. Yeah, you are asking something? Oh, yeah, you are right. Thank you. Yeah, you are right. Based on weight of the particle, very easy for me to write W, and this is wrong. Yes, thank you.
Area of solid particle or catalyst particle?
Catalyst particles. Yeah. Okay. And all solids are catalysts inside the reactor. Okay. So, I mean, when you are talking about packed bed, where I have gas solid catalytic reaction, we have taken only one example, gas solid catalytic reaction, right. Like for example, ammonia conversion or sulfur dioxide to sulfur trioxide with using vanadium pentoxide. So many definitions are existing only for that. Still, this is not the end. You can also, if you are crazy, you can also base it on voids of the voids inside the solids. It is not inside the bed. Inside the solids only I told you, inside the bed only I told you that we have around 0.4 for spherical particles, okay, and 0.6 if you have Raschig rings, and by the way, catalyst particles also are made in the form of Raschig rings. How does a Raschig ring look like? Never seen. What is your name? I have forgotten. Just Pooja. Yeah, Pooja. I have never seen Raschig ring. How many people not seen Raschig rings? Frankly. Otherwise, I will ask you to come and draw here. How the Raschig ring look like? You are not also not seen. Merit? No. Oh my God. Yeah. So, okay, can you tell them how Abdul? How does a Raschig ring? You also not seen. AC Tech, how I say? I think they have lots of They always have only Rashik rings only, holes. Okay. No, Ranganathan, I am not asking whether you have seen or not, but in AC Tech, Rashik rings are not there. Bell saddles are more difficult to make. Rashik rings are very easy to make. Okay. Rashik ring is just a cylinder with a hole. Okay. Like pen, yeah. This one you just cut here, take this portion, that is a Rashik ring. This is the simplest one because you are trying to utilize. If it is only cylinder, is closed, right. So, then area available for reaction is only the external surface, but now you put a cut here and cut here. If it is hollow, thickness may be, of course, it should withstand the weight and all that. Then internal surface are also is available for reaction. So, because internal volume also is available, that is why it goes to 60%, 0.6 is the voidage. Okay. And some people also use straight like this, exactly. This is the catalyst. It is a cylinder, but there is no hole. Okay. Cylinders are very easy to manufacture in the industry for as catalysts. Spherical particles are very difficult to manufacture on that scale. Yeah.
Powder particles like you're grinding something and you're making powder.
Very fine powder, no?
Yes, sir.
Yeah, I mean, are you MS scholar, PhD scholar, or PhD? Why don't you do that experiment in your lab? Which lab you are in? Huh? Oh, Tanmay Basak group. Yeah, I think in that transfer operations lab, you take a cylinder and then you try to pour that powder and try to find out what is the voidage.
Sir, that will basically clog in the bottom. What I can do is I can just place two support or two holes, the ceramic hole.
You do whatever you want, but they tell me what is the voidage. No, it's good. No, that is why many people think that the people who are working, who are doing the experimental work, the theoreticians feel that people who are doing experimental works are like laborers. Okay. But I think laborers definitely should have much more brain than the theoretical people, because theoretical people nowadays, that theory, you are not proposing E equal to mc square. Okay. You are only trying to solve some mathematical equations, but experiment when you try to do, how many things you have to imagine in your brain before you start the experiment. Even nut and bolt you have to choose. Okay. Literally you have to choose in our department, because we do not have nuts and bolts now in the department. Okay. We do not want to have any nuts. Okay. Yeah. So, I think it is it is not that easy. Everything you have to imagine, how do you do this experiment for the experiment to be done. That is why many people take the easiest route, go to computer, take one differential equation, solve, change boundary conditions, submit. The real engineering thing will come only when you are able to verify whatever theory you have done in your thesis with an experiment. So, that is why most of the engineering PhDs or MS research problems must be having both the components, theory and experiment. Otherwise, you are not an engineer. In fact, it happened when they go for interviews here, in what is that placement. People asked, have you seen, what is a rotameter? They said, no, we have never seen a rotameter. They were very angry, the people who are working theoretically. Okay. They were very angry and they wrote this big letter to director at that time. It was, I think, 15 years back or so. Okay. What is this? What kind of training you are giving in a chemical engineering department? They have got MTechs and PhDs, but they never seen a rotameter. Okay. You may ask, so what? So, why, if I have not seen rotameter, what will happen to this world? Nothing will happen to this world, but only thing is you will not get the job. Correct, no? Because they want, they definitely want some information about rotameter, I think some flow meters. Okay. So, that is why, yeah, that is a good question. I think I also told you, when you put very, very fine powder, what should be the voidage? It is nice spherical particles, you will get that. But if you have powder, that too irregular powder, you may not have each and everything as perfect sphere, then definitely it will be 0.2, 0.1, much less. But it will be challenging for you to determine exactly what is that. Okay. Because you are using very fine powder, for example talcum powder, you pack it and then or when talcum powder is put in that container where you use with holes perforations, you spray there and all that. Yeah. So then what should be the void edge there? That depends on again pressure, how much pressure you are applying when you are packing that. So that is not that easy to determine. That is why powders we never use in a packed bed, right. We use only minimum 3 mm particles, 5 mm particles. Of course, in industry, as I told you, the catalyst if they are using spherical, even then it will be half an inch particles, 10 mm, 8 mm, 6 mm, like that. Maximum I told you 18 mm. 1 inch, 2 inches, no one will go, because simply we are losing surface area. But if you are going to lower and lower 1 mm, 0.5 mm, 2 mm, the pressure drop increasing, because normally theoretically there should not be any change in void edge if you have perfect spheres. But who can make a perfect sphere? Even God cannot make perfect spheres, really. That is why He made all the planets, and most of the planets you see they are bulging in the middle like all of us. Yeah, really, because they also rotate, because always the first indication of prosperity is this one. Okay. So people look at that. Is why I used to analyze people in terms of straight lines. I told you already. Oh no, I always see the people as straight lines or cylinders or spheres. Okay. Straight line will be something like this. Somewhere you have legs, somewhere you have hands, but most of the time you see a single line. We can see some of the people when they are walking. Okay. All this, very long time back in Telugu, I don't know when some of the people who may be knowing Telugu people, there used to be one comedian called Ramana Reddy. Okay. Yeah, he was a straight line, because he does not have any other organism except, because one dimensional, you cannot put any other organ there, no. Okay. Yeah, the other person what I have seen, the other extreme sphere, was one of these singers, where is it not sphere? You cannot see head, only small, legs and all that hidden somewhere. Okay. So this is the one. So as engineering I am approximating that one as spheres. You can see that. Okay. And most of us are looking like this. Yeah. Okay, cylinders. So that is how I think we can see, we can look at the people and then think that, okay, my God, straight lines, spherical particles and cylinders, you can also divide them and you can use them as catalysts if required. But this will be a very bad catalyst, because packing is not possible so easily, right. Even this also is irregular, but that is what people use mainly in industry most of the time, because extrusion, how do you make catalysts? They will identify what is the material and they will make as a paste, and then they extrude through the extruder, like noodles they make, noodles also extrusion only. So, but they cut, normally L by D equal to 1, normally it can be even 1.5, but most of the time L by D, that means if diameter is 1 centimeter, length also is 1 centimeter, that is the kind of cylinders. Those cylinders they pack, and as Jahani was telling, irregular, random packing when they do, you will not get uniform porosity or uniform void edge across any cross section. That means when I take packed bed and cut at one point, I look there. So the void edge may not be uniform when compared to another cut just above. That is why we take what is called superficial velocity. Why do you use superficial velocity? By the way, what is superficial velocity? As I am talking as if all of you know what is superficial velocity. Yeah, what is superficial velocity?
Actual velocity to the.
What is your name? I want to remember names. Abhijit. Yeah, Abhijit. Huh? Oh, okay. I will equate with our Abhijit.
And is the velocity when actual void is divided by that area.
Which area?
Velocity.
Velocity you cannot divide anything. You have to take only volumetric flow rate and divide.
Volumetric flow rate divided by area.
Which area you are talking?
Exact wide area totally. When no catalyst is there, nothing is there.
Yeah. Superficial velocity, correct. Superficial velocity is based on only empty cross section. right. But in most of the packed beds you need packing definitely for the catalytic reaction to take place, but in spite of that we always refer to superficial velocity. You know the reason why? The reason is exactly I know what is superficial velocity, okay, because it is empty cross section divided by volumetric flow rate divided by empty cross sectional area. Okay. On the other hand, if I put packing, if it is not uniform void edge, at every point velocity is changing. So, I do not know how to correlate that. So, that is why a very good known parameter I will take, I will express all my correlations in terms of only superficial velocity, where we know the diameter of the column, we know the volumetric flow rate. So, you can get superficial velocity. If all the correlations are developed in that way, then it is easy for us to use them. Otherwise, the void edge will change depending on the packing, the void edge also will change depending on you have irregular packing, or even cylinders also it is not uniform. Only perfect spheres, if you pack them, that too maintaining L by D, now this time not L by D, D by dP, diameter of the column divided by diameter of the particle, minimum 10 and above if you use, then only you will have the uniform void edge. Otherwise, what will happen? Near the walls you will have more void edge, at the center you will have less void edge. But by increasing the diameter and putting only 100 particles, for example, across one diameter 100 particles, if you are able to put, most of the non uniformities will disappear. That is why we say assume, the people who are using these theoretical equations, all assumptions must they do. Assumption number 1, assume spherical particle, you will never get spherical particle. Assume uniform void edge, you will never get it. Assume no wall effects, okay, that is okay, you can get it, because depending on diameter of the particle and diameter of the tube, you may be very near to that assumption, right. So, that is why all that we do. Good. So, what is that I was telling now? Yeah. So, out of all these, as engineer, which one you choose? This is only for just gas solid catalytic reactions. Which is third one? Yeah, why? Correct. Easiest to measure. Easiest to measure. What is the difficult to measure out of all that? Surface area. You will never get perfectly all the surface area that is available for the reactions, because even when you are using different techniques, right, BET may give you some good information, but mercury porosimeter, this that will not cover the entire range of pores. Okay. So, that is why like this you have to write all possible things and then choose one of the easiest rate. Like for example, if I have liquid reaction, which is the easiest way to express? But you have in the volume both the things. Yeah, okay, very good. The volume of the reaction you can express. What is the most difficult to get?
Interfacial area.
In fact, estimation of interfacial areas are very, very difficult. Same thing even with the gas liquid systems, where you have bubbles, gas and then liquid as bubbles. So, then you will have again same problem. So, that is why you have to now understand that the first problem with heterogeneous system that comes is definition of rate itself. Okay. And one example I can give you here, GLS, when you have three phases, most of the time people express as bubble free slurry volume, moles converted per unit time per unit bubble free slurry volume. That means again bubbles, they may be of different sizes, different shapes. You will not have again spherical bubbles all the time, right, and also you will not have uniform bubbles all the time. So, that is why they simply eliminate, saying that okay, let me express the rate for this as moles converted per unit volume of bubble free slurry, that means solid volume plus liquid volume you take. But that is not the only unique way. Some people may say that only bubbles. Okay. I think when you take this time also we will tell, in the next semester we will actually derive an equation for the rates of slurry bubble columns, also sometimes called slurry columns or slurry bubble columns. So, there you will know it is most important thing is bubbles there first, the mechanism when you just look into. Okay. So, that is what is happening now with all these rates. You have to choose one of the easiest one which you can measure and industry can use that very easily. So, as I told you again I am repeating, when you use this equation then you will get directly weight of the catalyst. Okay. Or when you are using surface area, directly you will get surface area of the catalyst. Then you can convert. Finally, you should have only volume converted into some diameter and some height. That is what is ultimate shape of the reactor. Okay. Spherical reactors many people won't use, very difficult to make again. Spherical reactors most of the time either tanks only, right, cylindrical. Most of the time it is only cylindrical. So, that is why you have to choose a diameter, you have to choose a height. Good. Yeah. So, I think I have covered, I wanted to cover many, but this time I think yeah. So, I thought of doing I think even batch reactor. So, next tomorrow class we will concentrate on contacting. So, this is the information what we have now. In fact, this is what we have to write also in the design expression when you are writing the balance. That is why I thought I will just say the definition of the rates and all that, our key reactant always is A. That is why we will call minus Ra, right. So, we will use that information to now write design expressions for batch and then continuous, and I also discuss with you when do you choose continuous, when do you choose batch.